Hello and welcome to week 6 of Advanced Exercise Physiology at Concordia, and I'm Professor Mark Baines. A few things to think about as we go into this sixth week. First and foremost, when it comes to your posts, let alone your paper you just turned in, you should have already turned in. Spelling and grammar, although I don't specifically tell you where you misspelled everything or where you're grammatically incorrect or not precisely stating things, you are going to be knocked down. If it's more than an error, a simple error or two, if there's several, you're going to be knocked down at least a few points for your posts. Please make sure you're proofreading. This is an ongoing thing that should be happening throughout anything you turn in at any time, whether it's a resume or anything, right? We all know this, but we don't take the time. I know time can be challenging, but you need to take the time to do that. It's going to hurt you in points. And ultimately, it hurts you in getting across your message, and we don't want to do that. And then beyond that, attaching and linking the journal articles. Several of you, most of you, if not even all of you, have gotten much better at making sure you cite at least one peer-reviewed research journal in your first post. And if you forget to do it, then later on you need to go back in there during the week to make sure you're doing that, because you're not graded on just what you get in on Wednesday, but of course over the course of the week. That first post needs to be strong, it needs to have your citations, but if for some reason you miss it, make sure it gets in there. You're still going to get points for that. But you also need to make sure you're linking it, so we specifically can click on a link and see the article. Or you need to attach it in PDF form so we can download it and look at the article. You're going to lose points if you don't do that, so make sure you're doing that, okay? As far as exercise goes, something to think about for things we've covered in the first few weeks. We talk about readiness for multiple sets. You're going to do a drill, an exercise, whatever it is you're going to do. Running, lifting weights, anything. You're going to do a work period, and then you're going to have a rest period, and followed by another work period, right? Make sure the person has achieved a level of heart rate whereby they can perform the next set at a reasonable level. Make sure that they feel ready to go. All those things. More than anything else, they need to improve from one set to the next, or at least be able to perform it exactly the same way. Coordination needs to be the same. Force output needs to be the same. More importantly than whether heart rate is the same or RPE is the same, performance must be. If it's not, that's when we look to RPE and heart rate among two primary factors, if not the most important factors, both perception of intensity as well as heart rate response regarding the force output and how much skeletal muscle involvement there is that requires more and more blood flow, requiring more and more of an increase in heart rate when stroke volume decreases, right? We want to make sure that we have enough rest. Too much time is spent upon worrying about how much time we have rest-wise between days, or what you do with your water and your nutrients and your rest between days without taking enough time to think about rest between sets. It doesn't mean you're wrong to not focus on those things. Everyone should, and I think a lot of you, based on what I'm seeing in your posts, are particularly aware of how important it is for rest between days, rest between sessions, and things you need to be doing to prepare yourself for the next training session. And we like to say training session rather than workout because training session implies something significant, something that was planned, whereas workout implies random. I'm going to go work out, and that can mean any number of things. So training session may be a better choice to use with your athletes or anyone you work with to remind them this is significant and there's an actual plan here. It's not just a random series of movements and exercises. But that's how we generally judge someone's readiness for multiple sets. Perform at the same level or higher. Otherwise, the intensity is too high. This whole concept was coming too soon without enough recovery between days, possibly. But if they did one set, the expectation should be you should be able to do a second set at relatively similar level if we have the right rest and if we're programming at the right level. As far as the VO2 max, aerobic capacity to max heart rate relationship. Now, max heart rate, remember, it's a theoretical number. We wouldn't really know exactly what someone's max heart rate is because they actually would die. That would be their max heart rate. They're gone. That was the max heart rate. Write that down. Kind of not useful to us right now. But that max heart rate, old school formula is 220 minus your age, I think is a very fair formula, being one simple reason. There are more accurate formulas that have been created the last several years, that will account for a few beats difference, either higher or lower, because what their concern is to overestimate or underestimate maximum heart rate. But we're really using it as guidelines. We start figuring out zones, whether it's VO2 max percentages or max heart rate percentages. We want to know what they are, have a rough idea of what they should be, and theoretically, performance is at a high level when they're in those areas. If performance is not at a high level, and we're in that VO2 max range we're expecting or heart rate range we're expecting, it doesn't matter. It's too highly intense. Got to drop the intensity down. That said, max heart rate and VO2 max do not vary the same way. It's not a linear relationship that the moment heart rate goes up, VO2 max goes up the same level. It does not. Actually, VO2 max tends to be typically lesser than max heart rate. So when you're in that 40 to 60% of VO2 max, you're really in that 60-65% max heart rate and above. So it's not exactly the same. And that's, of course, why I gave you the website that had the formula, because it's a mathematical formula you need to be using for recognition of max heart rate versus VO2 max. You're not so much concerned about VO2 max when it comes to strength training, of course, but max heart rate percentages should always be a point of awareness for any type of activity, whether it's cardiovascular activity or strength training activity, weight room, track, basketball court, field, pool, doesn't matter. Ideally, you should have heart rate monitors on all your athletes. Totally understandable if you don't have that. Totally understandable. That's why you should be taking at the end of every sequence or set, everybody stop and preferably put their hand on their pulmonary artery at the wrist. If not, then at the carotid. Carotid is a little bit less likely to be as accurate for most people. But 6 seconds, add a 0, that's the current heart rate. Okay? And you'll start to get a feel for that. We start writing that down, recording that. You'll know that if a person's not able to perform the next set, whatever the heart rate was, make sure it gets lower next time. That's why I have to track all this information. Didn't say it was easy. Being a great coach really never is for any of us, right? Important concepts for this week, going into week 6. The concept of hydrogen ion accumulation as it relates to ATP muscular contraction. When a muscle contracts, of course, lactate, not necessarily lactic acid, it's often used as the phrase lactic acid development. So lactate is increasing at a very significant rate. We start getting that point of nearing fatigue or that burning sensation that happens more in the glycolytic phase of energy production. You're not going to see that during ATP, CP, or endurance-related activity. It's when you're reaching a very high level and your body's having the inability to both replenish ATP and remove the excess hydrogen ions. Those excess hydrogen ions are a response from the transfer of energy with ATP broken apart, the bond broken apart, and you have the ADP and the inorganic phosphate. What you essentially end up with is excess hydrogen ions, these basically, and they're trying to bond with the muscle fibers, which then takes the place, inhibiting muscular contraction, tries to take the place of where calcium tends to bind with troponin at the muscular fiber site. Consequently, not only does it make it hard to both replenish ATP and remove metabolic waste of hydrogen ion accumulation, but also it makes it very difficult to even have muscular contraction at all because hydrogen ions are trying to take the place of binding at the muscle fiber site. And that's why we take a rest when things get hard. We don't keep pushing through those difficult times. It's a very common error that we all learned in physical education and through some of our past coaches. We need to do better. And the concept of intracellular buffering and increasing acidosis, we just referred to kind of the concept of increasing acidosis or the pH lowering as the activity level increases to a high level intensity. What's happening is, of course, with that acid is related to the hydrogen ion accumulation. The acidosis in the blood, your body is trying to remove that acid base and then try to bring the pH up, right? Try to remove those hydrogen ions. And your body has all sorts of cellular buffering agents, sodium bicarbonate, phosphates, histidine, carnosine, all sorts of internal responses to be able to help buffer that metabolic acidosis. And that said, it's trying to remove that acidosis or the hydrogen ions and whatnot, trying to bring them into the interstitial space between muscle fibers, trying to take them out of muscle fibers so the blood can then actually take it away, remove it, and then replenish again and start over again and come back and do it again. Now, a lot of people try to take sodium bicarbonate, basically baking soda, and phosphates and other supplements in trying to buffer that acidosis. You have to really be careful with that. That is something that we get way too carried away with being a primary emphasis when the first and most important thing is, from a standpoint of training, making sure we're training properly. Make sure you are absolutely clear that you understand the different energy systems, different muscle fiber types, work rest periods, and why, long before you start worrying about taking in supplementation to reduce acidosis. First things first. And of course, we have to eat a good diet and get plenty of water. And then we worry about those things. Don't get in too much of a hurry to do things that are not the most important things. Doesn't mean they can't improve performance, because they can, but first and foremost, we have more important priorities. As it comes to fast and slow twitch fibers actually have a higher buffering capacity, but it's also not going to see fast twitch muscle fibers last very long, right? The type 2B or type 2X, we should say. Type 2B was a former name used for that particular muscle fiber, but now we realize that animal muscle fibers and human muscle fibers are not the same. So now we refer to muscle fibers that are fast twitch in humans as type 2X, animals type 2B. Those type 2X muscle fibers only last a few seconds. And then, of course, the type 2A muscle fibers, I should say, only become the most important or primary emphasis for the first few seconds. They're still involved at any time during activity. They're the primary users or primary muscle fibers involved in the really explosive activities, right? Short duration bursts. Whereas the type 2M muscle fibers are more moderate. They're involved primarily as the primary emphasis point for up to a couple, 2 or 3 minutes, where then the type 1 muscle fibers kick in. Now, even though it is true that the fast twitch muscle fibers have higher buffering capacity, they still don't have the ability to last for longer periods. So it's really one of those pieces of information that doesn't really necessarily help us in what we do, other than understanding that that's how they're able to perform at such high levels of work. They have a higher buffering capacity to enable them to work at higher levels of effort, higher levels of force output, to produce more force, but they have a higher fatigability, unlike type 1 fibers, they don't need that same buffering of acidosis capacity that type 2 muscle fibers do, and that's why. As far as breathing and skeletal muscle effort, making sure we understand that just because you're working harder does not necessarily mean you're breathing faster or breathing more frequently. It depends on numerous factors, and that's one of the things we're trying to explore in this last week when it comes to ventilatory control. One of the things I was trying to urge you to think more clearly about. It's beyond not just your involuntary capability. You can only control your breathing to so much of an extent, but you can control it through the proper focus, proper preparation, proper nutrient intake, proper levels of intensity. People can actually control our breathing much more so. Being much more upright, taller, upright spine, you're breathing much better. The tendency is when we get tired to crouch, lean over, thereby actually inhibiting our ability to actually utilize oxygen quite so well at higher levels of aerobic type work. We're moving into anaerobic past our anaerobic threshold into high intensity work. But skeletal muscle effort increase. As it increases exponentially or significantly through multiple muscles, that's when you start seeing more of a rapid increase in breathing. What you're basically seeing is that particular individual is having a significant skeletal muscle effort requiring the increase of breath, trying to utilize more oxygen, helping to assist with the process of conversion of ATP into energy usage, to assist blood flow, all those things. So perfect world, you have high skeletal muscle effort, this should not be a surprise, with less heavy breathing. It is not a goal to get the person to breathing hard. It's not a goal to get the heart rate up. These are things we now need to know and be better at. Now that we have the information available to us, use it to our advantage to train our athletes better, not just harder, right? Of course, now in this sequence of chapters 11 and 12, temperature and humidity is a big discussion point. It's always difficult trying to figure out when things get too hot or too cold. Do we still train? Should we not? And a lot of that has to do with acclimation, as your chapter notes. It's about 7 to 14 days for an athlete to become fully acclimated, generally speaking, as acclimated as they can get to more significant cold and more significant heat and humidity. That said, we're talking about adaptation of blood pressure, blood flow, getting past muscular fatigue-related issues, sweating at a proper rate, all those things. 7 to 14 days, at least. That being said, if you knew you had a high-level competition coming up where it was really, really hot, perfect world, you'd be in a high-level heated area that was similar to that conditions of that place, so you could actually acclimate properly to it. We can't always control these things. We can't always control the temperatures we're in, but we want to do the best we can with that. And when it comes to higher heat areas, or areas where the heat's can be significantly high, or humidity is significantly high, or both, preferably making sure they drink more water than normal. Bar none, at least 16 ounces 2 hours before, 1 hour before, and a half hour before. That's 48 ounces in the last 2 hours prior to activity. Preferably cold water, right? Being in a cooler place in the time leading up to practice or to the training session would be ideal, perfect world. Putting ice or a cold shower, a cold bath, not a bad idea either, because when it is hot, the blood is actually rushing to the skin, which is why we get so hot, why we sweat more theoretically. A person theoretically should sweat more if they're higher conditioned for heat. They should be the first person to sweat and be able to sweat for longer, because of course the greatest fear is in high heat situations, heat exhaustion first and foremost, where the person is excessively sweating, more so than they would normally do, having a difficulty functioning normally. You should know this long before it actually happens, because performance wanes. It's time to consider taking longer breaks or getting more water or quitting, not keep going. We see it in football and other team sports where it's harder to pay attention to individual athletes. But generally speaking, we have to do a much better job as coaches to make sure this does not happen. It's not a rite of passage to be throwing up and getting and passing out on the field during practice. That is actually showing a sign of a bad coach. It's not a positive thing at all. Those things should not be happening. We can do better than that. Extreme cold, which of course happens a lot more in the Midwest and the northern regions than anything else in the United States or other areas of the world, beyond where we typically see like Northwest, West Coast, and southern areas of the US, where it tends to be not quite as cold, generally speaking. But colder temperatures, I'm going to make sure the person has layers, thin layers, so they can delayer from the point of starting the activity to getting more and more warm as the time goes on, right? Making sure the person's dressed accordingly, very, very important. Let alone hydration is, again, vitally important. Same idea, that 16 ounces 2 hours before, 1 hour before, half hour before, which should happen with activity anyway, but it really needs to be happening for hot and cold temperatures. You'll see some slight variations in how the textbook refers to liquid during activity. They'll refer to 150 to 300 milliliters of water every 15 to 20 minutes. I've often seen a lot of studies where it's more like 10 to 15 minutes, 6 to 8 ounces. So you're looking at anywhere from the low end of 6 ounces every 20 minutes to the high end of 8 ounces every 10 minutes. That's kind of what you're looking at as far as the range of activity. When activity engages for an hour plus of significantly fairly vigorous activity, more endurance athletes typically speaking, but anyone on the football field, that's when that Gatorade drink needs to be out there. Some drink that's 6 to 8% carb solution relative to water, not watered down, 6 to 8% solution, because that's what you need to get a proper hydration level and get nutrients in your body, because glycogen stores are decreasing for those hour plus activities. Something to think about in hot, cold, or any environment. Metabolism lowers as it gets colder or the body cools. As the body gets hotter, just like with the temperature outside or the activity itself, metabolism picks up. However, why heat stroke and heat exhaustion happen is when you're heating up because of activity and it's hot and humid, you're going to see more likelihood of heat stroke and heat exhaustion. Heat exhaustion is the first stage, and heat stroke, if an athlete ever gets to you with heat stroke, it's either because you had no ability to be watching or you're not watching enough. Adequate preparation can really, really stem the concerns that we have with extreme heat, extreme cold, making sure you're taking the time to do so, making sure you're taking the time to make it clear to me and to your fellow students you understand how to deal with those situations, whether you have to or not. You should know it in case it does come up, because randomly maybe your team has to travel to some location where it's going to be extreme cold or extreme heat, and your athletes are not normally ready for that. You need to know how to best prepare them to deal with such stress. Exercise is stress, but stress is not always a good thing, right? Distress is stress we can't recover from properly and can't get benefit from. Eustress is the kind of stress that's only just enough to get us 1% better, that challenges us a little bit beyond our current physiological capabilities, not that overly challenges us, and we can recover from it. If we can, get a positive result. That said, we've reached the halfway point in this course. So far, so great. I'm very impressed with how well you're doing on your discussion board posts. I hope to keep seeing improvements, because that's the whole thing. You're going to be graded a lot, not just on the fact you're performing well, but increasing your level of performance. If you're already performing at a high level, you got to maintain it, of course. But if you're not, that's okay. There's plenty of time. Make sure you are continuing to respond to one another significantly, not just a couple sentences, not just say good job, but specifically asking questions. What do you think about this? You bring up an interesting point, which a lot of you use that exact phrase, but then say, what do you think about this? How would this relate to that? There's a chance they don't respond to you. You can't control what other people do. All you can do is the best that you can, and I expect you, fully expect you, to be taking the time to respond to each other and ask questions, whether or not they respond back to you or not. Lastly, call or email if you have questions. If there's anything else we can do for you, that email is something you should always utilize. And if I don't respond to you within 24 hours, then you can call, and their phone number, the office number is on there as well. So you can actually call me by phone if you want. We can arrange a phone call if you want as well. I want you to do well. I want you to keep getting better. I want this to be very, very valuable for you. I know at times it can be hard. It is what it is. Sometimes things are just difficult. Hopefully it's fun. Hopefully you're having a good time with everything we're covering. At the same time, I know it is work. Keep getting after it, and I look forward to talking to you again soon.